All right, let's jump right in. We're going to tackle one of those big, fundamental questions about how our digital world actually works. I mean, really think about it for a second. You send a message, you're streaming a movie, you're just browsing a website. Your app is talking to a server that could be miles or even continents away. How in the world does that data get from your screen to some other machine and back again? Well, the answer, it all comes down to something called a socket.
So what is a socket? The best way to think about it is like a doorway. It's the one and only interface between an application, the part we developers actually write the code for, and the transport layer, which is all managed by the operating system. Your app literally hands a message off to this doorway, and the OS takes over, handling all the messy details of packaging it up and sending it out onto the internet.
Okay, to really get a feel for this, we're going to build a super simple client-server app. It's a classic example, but it's perfect for showing us exactly what's going on under the hood.
So here's the plan. Our client app is going to take some text that you type in. Then it'll shoot that text over to a server. And the server's only job, it's just to shout it back by converting it all to uppercase. The server sends it back and our client displays it. Sounds simple, right? But here's the thing. To actually build this, we have to make a pretty important choice right up front.
We've got two main ways to send our message through that socket doorway. Think of it like this. We can use what I call the postcard method. It's fast, it's simple, but there's absolutely no guarantee it'll get there. Or we can use the phone call method. This one is super reliable, totally ordered, but it requires a little more setup before we can actually start talking. And these two methods, they map directly to the internet's two main transport services.
All right, let's start with the postcard. In the networking world, this is known as UDP, which stands for the User Datagram Protocol. And these points right here, they perfectly explain why we call it the postcard method. With UDP, there's no formal connection. You don't call ahead to see if the server's ready. Nope, you just write the server's address on your little packet of data, drop it in the mail, and, well, you hope for the best. It's incredibly fast because there's no setup involved. But, and this is a big but, that postcard might get lost in the mail. Or even weirder, it could show up after another postcard you sent later. And check this out. This diagram shows the flow perfectly. The client creates its socket, its doorway, it takes its message, slaps the server's IP address and port number right on it, and just fires it off into the socket. Meanwhile, the server's just hanging out, listening. When a packet finally arrives, it reads it, does its thing, and sends a reply back, making sure to put the client's return address on it. It's a super direct, no-frills kind of conversation.
Now, if we look at the actual Python code, you can see just how simple this is. The one line that does all the heavy lifting, the key moment, is right here. Client socket.sendTo, this is it. This is the exact moment our app drops that postcard in the mail. See how we pass in our message, and then we have to explicitly tell it the server's name and port number every time? That's really all it takes.
The server code is just as beautifully simple. It creates a socket and basically binds it to a specific port number, in this case port 12,000, so all the clients know where to send their postcards. Then it just sits in this endless loop, just waiting. The magic command here is receive from. It's just patiently listening, waiting for any postcard to show up in its mailbox, ready to grab it and get to work. Okay, so that's the fast and loose postcard method. But what if you absolutely, positively need your message to get there? And not just get there, but arrive in the right order. Well, for that, my friends, we need to make a phone call. And that brings us to TCP, the Transmission Control Protocol. So, totally unlike UDP, TCP is what we call connection-oriented. You have to actually establish a connection before you send a single piece of data. It's exactly like dialing a phone number and waiting for someone on the other end to pick up and say, hello. This whole initial setup process is called a handshake, and it's what guarantees that your data will arrive reliably and in the perfect sequence. It basically creates a dedicated private pipe between the client and the server.
And this diagram here shows exactly how that connection gets built. See that extra step right at the beginning, the TCP connection setup? The client reaches out, the server accepts the call, and only then does the data start to flow. It's this formal process that makes sure nothing gets lost. But this formality introduces a really interesting and kind of tricky new concept on the server side.
Wait a second. You might notice something a little weird here. The server diagram, it shows two sockets. What's up with that? No, that's not a mistake. And honestly, this is probably the single most important concept to really get about how TCP servers work. It can be a bit of a mind bender at first, so let's break it down.
Okay, here's the crucial idea. The server has one special socket, which we'll call the welcoming socket. Its only job is to listen for incoming calls. Think of it like a company's main receptionist, just sitting by the phone. When a client calls in, the receptionist, that's our welcoming socket, doesn't handle the entire conversation. Of course not. Instead, it creates a brand new, totally dedicated socket, a connection socket, and hands the client off to that private line. This is brilliant because it frees up the receptionist to immediately answer the next call, which is how a single server can handle tons of clients all at once.
Now, over in the client's code, we see this phone call happen with one simple command, clientsocket.connect. That's it. That's the code equivalent of dialing the server's number and waiting for it to pick up. As soon as that command finishes, the connection is live, the line is open. And from that point on, we can just use send to fire our data right down that pipe. No need to specify the address every single time like we did with UDP.
And now for the server code, which really brings that whole receptionist analogy to life. So after it sets up its welcoming socket using listening, it calls this, serversocket.accept. This command right here, this is the server waiting for the phone to ring. It just hangs there until a client connects. And when one does, accept performs its magic. It creates and returns a brand new socket, the one we're calling connection socket. That is our new private line. All the back and forth with this specific client from now on happens through that dedicated socket. So there you have it. We've just looked at two very, very different ways to get a message from point A to point B. One's a postcard, the other's a phone call. So, which one's better? Well, like with most things in tech, the answer is it depends entirely on what you're trying to do.
Look, if you remember only one thing from all this, let it be this right here. UDP is like sending a postcard. TCP is like making a phone call. That's it. That one analogy perfectly captures the fundamental trade-off between speed and reliability.
Let's just break it down one last time. UDP, our postcard, is unreliable but fast. This makes it absolutely perfect for things like live video streaming or online gaming. Think about it. If you lose one single frame of a video or one packet in a game, it's not the end of the world. Speed is what matters. On the other hand, TCP, our phone call, might be a little slower to get started, but it is rock-solid reliable. It's absolutely essential for things like file downloads, your emails, and just general web browsing. You know, situations where every single byte has to arrive perfectly intact and in exactly the right order.
So next time you're binge watching a show or sending a super important email, just take a second and think about it. Is this app sending a quick postcard, or is it making a careful phone call? You actually have the tools now to make a pretty good guess. Thanks for hanging out and digging into this with me.